Hi everyone, welcome to the session on Agile methodology. In this session, we will see what are the keys of Agile engineering practices we are using, that is, test driven development, continuous integration, refactoring, pair programming, simple design, user stories, Agile testing, Agile tools. So we will see one by one. The first one is the test driven development. It is a development approach where tests are written before writing the actual code. This ensures that every feature is clearly understood and tested from the beginning. So, resulting in fewer bugs and higher code quality. And next one is the continuous integration. Continuous integration means developers frequently merge their code into a shared repository, often several times a day. Automated builds and tests run after each merge to catch the integration issues early. And next one is refactoring. Refactoring is the practice of improving the structure of existing code without changing its behavior. It keeps the code clean, readable, and easy to modify in the future. Next one is pair programming. The pair programming, two developers work together at one workstation. One writes the code while others the reviews it in real time. This improves the code quality and encourages the knowledge sharing. And next one is the simple design. Agile follows the principle of do the simplest thing that works. The focus is on building only what is needed now, avoiding unnecessary complexity and over design. And next one is user stories. User stories are short descriptions of a feature written from the user's perspective. They help teams understand customer needs and build software that delivers the real value. And next one is agile testing. Testing in agile happens continuously during development, not at the end. Agile testing ensures the quality through early defect detection, automation, customer feedback. And next one is Agile tool. Agile teams use tools like Jira, Trello, Jenkins, Git, Selenium to manage the task, automate builds, track progress, and maintain the transparency throughout the project. Now we will see the one by one topic. So how is implemented in Agile methodology? The first one is test driven development. What is the test driven development? Here, the core concept is test driven development requires writing tests before code, guiding the design and ensuring the correctness. Test driven development is a software development approach where we write the test cases before writing the actual code. This helps developers think clearly about what the code is supposed to do. By writing test first, we ensure that every piece of code has a clear purpose and behaves correctly. And next one is XP practice. Promoted in extreme programming, test driven development is one of the core engineering practices of extreme programming. Extreme programming promotes the high quality code and fast feedback. Test driven development supports this by preventing bugs early and improving the code reliability during the agile development. A test first philosophy. Begin by writing a failing automated test, then only enough code to pass it. Test driven development follows the simple cycle called red green refactor. Red, write a test that fails because there is a no code yet. Green, write the minimum amount of code needed to make the test pass. Refactored, improve the code quality without changing its behavior. This approach encourages the simple, clean, and testable code. So, test driven development makes the development more reliable by ensuring that testing is not an afterthought but an integral part of the coding process. And next one is the business benefits of the test driven improved quality. Unit testing central to test driven development can reduce the bugs by up to 35%. Test driven development improves the software quality because each piece of the code is tested as soon as it is written. Since unit tests are central to test driven development, defects are caught early. Studies shows test driven development can reduce bugs by up to 35%, which leads to more reliable software and fewer customer complaints. And next one is increased throughput. Early fault detection reduces rework, boosting the productivity. By detecting the faults early during development, test-driven development prevents defect from spreading to later stages. This reduces rework and delays, helping teams move faster. As a result, the overall productivity or throughput of the team increases. And next one is reduced operating expenses. Test less non-value adding work cuts the operating cost. Test driven development minimizes non-value adding work such as fixing the late stage bugs, debugging complex failures, and dealing with the production issue. This saves both time and money, reducing the overall project cost. And next one is better design. Write, writing test first inspire the simpler, more modular, maintainable code. Writing the test first forces the developer to think about the functionality and the purpose of the code before writing it. This leads to simpler, cleaner, and modular code that is easier to maintain and extend in the future. So, overall, test driven development is not just a technical practice, it also delivers a significant business value by reducing cost, improving the quality, and increasing the productivity. In next slide, we'll see the test driven development in practice. Iterative cycle, write a failing test, write code to pass, refactor. Test driven development is followed by step in a short development loop. First, we write the test that will fail because feature is not implemented yet. Then we write just enough code to make the test pass. After that, we refactor the code, clean it, and improve its structure without changing its functionality. This cycle is repeated for each new feature. Focus primarily on unit test. In test driven development, the testing focus is mostly on unit tests, which check individual components or functions of the software. This ensures that each small unit behaves correctly before integration, making the system more reliable. And next one is automation uses framework like JUnit for rapid feedback. Test-driven development makes a use of automation tools like JUnit for Java, NUnit for .NET, or PyTest for Python. Uh, to automatically run tests, automated testing gives developers quick feedback and helps catch the issues as soon as they occur. Last one is the developer empowerment. Immediate issue identifications ensure lasting code quality. With a test-driven development, developers receive instant alerts when something breaks. This early detection builds confidence, reduces dependency on testers, and encourages developers to write clean, maintainable code from the beginning. Test driven development in practice is a disciplined development approach that builds quality step by step through the continuous testing, automation, and clean coding. In continuous integration, what is continuous integration? Continuous integration is a software development practice where developers frequently integrate or merge their code changes into shared repository. Each integration is automatically tested to catch issues early. What frequent merge code into shared repo followed by automated builds and test. In continuous integration, developers don't wait for the end of the week or month to combine code. Instead, they integrate code many times a day. After merge, the system automatically builds the code and run tests to ensure nothing is broken. Extreme programming practice key element making integration nearly invisible. Continuous integration is one of the important practices of extreme programming. By integrating small changes frequently, teams avoid large integration problems that often occur at the end of the traditional project. Automation uses tools like and for frequent builds. Automation plays a major role in continuous integration. Tools like Ant, Maven, Jenkins, GitLab, CI, or GitHub Actions automatically build and test the code whenever changes are made. This gives developer fast feedback, often within minutes. Policy integration frequency is a team organization choice. Extreme programming suggests nearly constant integration. Teams can decide how often they integrate, but extreme program recommends integrating as often as possible even after every small task. This reduces integration conflicts and ensures the stable software at all times. So continuous integration improves the team collaboration, catches the bugs early and keeps the software always in a working state. And next one is continuous integration in practice. Build tools and similar tools automate the builds test at each commit. In continuous integration, automation is essential. Tools like Apache, Ant, Maven, Jenkins, and Gradle automatically compile the code and run tests whenever developers commit changes. This avoids manual builds and ensure consistency across the team. And next one is the frequent commits. Developers integrate many times per day. Instead of waiting for the end of the day or sprint, developer commit changes frequently, sometimes multiple times a day. These small commits reduce merge conflict and make it easier to detect issues early. Rapid feedback, immediate alerts for build issues. Continuous integration servers give instant feedback if a test fails or the build breaks. The team is immediately notified, usually by mail, Slack message, or dashboard alert. This rapid feedback helps developers fix problems before they grow. And next, a scalability note might be challenging for teams greater than 12 developers. That continuous integration works best in small to medium sized teams. When team size increases beyond 12 developers, merge frequency and code conflicts increase. To scale continuous integration, larger teams often split into smaller features teams and use branching strategies like Git flow. So, in real world practice, continuous integration brings discipline to development by combining automation, teamwork, and fast problem detection. And next one is refactoring. What is refactoring? Here, the core concept is improving the internal code structure without changing the external behavior. Refactoring means cleaning, reorganizing the code to make it better, but without changing what the program does. It improves the internal structure so that the code becomes easier to read, understand, and modify. XP practice integral to ongoing code health in Agile. Refactoring is a key engineering practice in extreme programming. In Agile, requirements change frequently, so the code must stay flexible. Refactoring helps keep the code base healthy over time. Here, the goal is simplify, clarify, and create more change tolerant Agile code. The goal of the refactoring is to remove complexity, improve clarity, eliminate duplicate or messy code. Clean code is easier to adapt when new changes are required, making the software more agile. At times, ongoing small efforts are dedicated iterations. Refactoring can be done in two ways. Continuous refactoring, small improvement done regularly during development. Planned refactoring, dedicated refactoring sessions or sprints focused only on improving the code. Both approaches help maintain the code quality over time. In overall, refactoring keeps the software clean, maintainable, and ready for future changes without breaking the functionality. And business implication of refactoring: better code and design, simpler, less buggy code boosts stability. Refactoring improves the structure of code, making it clean, simple, and easy to understand. When When unnecessary complexity is removed, there are fewer bugs and the software becomes more stable and reliable. This boosts customer confidence and reduces failure in production. Increased future productivity reduces the technical debt, easing the future changes. Technical debt refers to the problem caused by quick and messy coding done in a hurry. If not handled, this slow down the future development. Refactoring reduces technical debt by cleaning the code early, which makes the future enhancement faster and easier to implement. The next one is the reduced rework. Addresses design flaws early, minimizing the costly fixes later. Small design issues, if ignored, becomes a major problem later in development. Refactoring catches these design flaws early, preventing the big rework at later stages. This saves time, effort, and money for the organization. Impact on metrics may lower immediate output but increases long-term efficiency. Some teams may feel that refactoring slows them down initially because it does not add new features immediately. However, in the long run, refactoring leads to faster development, fewer bugs, easier maintenance, and the increased team efficiency. So, it is smart long term investment. Overall, even though the refactoring does not produce visible result right away, it delivers the long-term business value by improving quality, reducing cost, and speeding up future development. And next one is the refactoring in agile workflow. Continuous embedded into daily agile work. In agile development, refactoring is not a one-time task, it is part of everyday coding. Developers keep improving the code continuously as new features are added. This prevents the code from becoming messy over time. Dedicated iterations, special sprints may focus solely on refactoring. Some agile teams schedule refactoring sprints or hardening the sprints that focus only on improving code quality. No new features are added during these sprints, only cleanup and optimizations is done to maintain the long-term code health. Trigger. Testing bugs often prompt refactoring tasks. Many refactoring tasks are triggered when bugs are discovered during testing. When a bug appears, it often reveals a deeper design or structure issue in the code. Refactoring helps fix the root cause instead of just patching the bug. Supported by modeling FTD domain neutral component modeling minimizes the refactoring needs. Feature driven development uses the domain neutral components, common reusable components, since they are well designed from the start. They reduce the need for future refactoring. Good modeling early helps minimize the code rework later. So in Agile, refactoring is a continuous process supported by the testing and good design model, helping teams maintain the clean and adaptable software. And next we will see the pair programming. What is pair programming? Pair programming is an agile software development practice where two developers work together on the same code at one workstation. It is a collaborative method that improves both the quality and learning within the team. Core concept: two developers co-create code at one workstation. In pair programming, one developer writes the code called the driver, while other reviews each line of code in real time called the navigator. They frequently switch roles to maintain the focus, share responsibility. XP Allmark signature XP techniques for code quality. Pair programming is one of the key engineering practices in extreme programming. Extreme programming promotes high quality development, and pair programming supports this by ensuring the continuous code review and faster error detections. Collaborative, continuous peer review and knowledge sharing. This practice encourages teamwork and prevents the knowledge isolation. Since two people share ideas and discuss approaches, the solution becomes more effective. It also spreads the technical knowledge across the team. Objective: drive quality and share understanding. The main goal of the pair programming is to improve code quality, reduces bugs, and build a shared understanding of the system. It also helps junior developers learn from the seniors, improving the overall team capability. Pair programming enhances software quality, team collaboration, and knowledge transfer, making it a powerful agile development practice. And next one is the business benefits. Quality boost can cut defect by up to 50%. Since two developers are reviewing, writing the code together, bugs are caught immediately. This reduces errors early in development, improving software quality. Study shows pair programming can reduce the defect nearly half compared to the solo programming. Increased throughput. Immediate fault detection increase the productivity. By preventing the bugs early, developers spend less time fixing the issues later. This reduces rework and allows the team to progress faster. As a result, productivity increases and delivery happens more smoothly. Knowledge transfer reduces buzz factor, risk, speeds learning. Buzz factor means how many people in your team have critical knowledge. If they leave, the project suffers. Pair programming spreads knowledge among the team members so that the information is not locked with just one person. It also helps junior developers learn faster from experienced developers. Better team dynamics promotes the self-help, mentorship, and shared ownership. Pair programming encourages teamwork and collaboration. It promotes the mentoring, improves the communication, and ensures that everyone understands the code base. This builds the trust and shared responsibility within the team. So, pair programming not only improves the technical quality but also brings the strong business value by reducing the risk, improving the productivity, and building the strong development team. And next one is the pair programming in practice. Real-time review. Every line double-checked while written. In pair programming, code is reviewed instantly as it is written. One person writes the code while the other reviews it simultaneously. This prevents error from ongoing unnoticed and improves the code quality from the start. Psychological upside, collaborations, job satisfaction, higher motivation. Working together improves the team morale. Developers feel supported, motivated, and more confident. Pair programming also reduces stress as developers don't feel alone when solving the complex problems. Good for immature teams, especially effective in high defect environment. Pair programming is very helpful for teams that are new. In experienced are struggling with too many bugs, it helps stabilize development by improving the discipline and sharing knowledge, especially when the code quality is inconsistent. It integrates with the TDD, CI forms of the feedback loop across the agile quality in practice. Pair programming works very well with the test-driven development and continuous integration. Together, these practices create strong feedback loop, write code, test it, review it, integrate it, and improve continuously. In real-world agile environments, pair programming strengthens the teamwork, prevents the defects early, and supports continuous quality improvement. And next one is simple. What is simple design? Simple design is an agile principle that encourages building software in the simplest way possible without adding unnecessary complexity or extra features that are not needed right now. The core concept build only what's needed, avoid excessive complexity. The idea is to solve the current problem and not over engineer the solution. Instead of trying to predict and build everything for the future, teams focus only on what is required today. This makes development faster and reduces confusion. Agile Manifesto Simplicity. The art of maximizing the amount of work not done is essential. The Agile Manifesto highlights that simplicity helps us avoid wasting time and effort. By not building unnecessary features, the team stays focused and delivers faster with a higher quality. Evolutionary. Let design emerge incrementally, not in a big bang. Instead of doing heavy upfront design, Agile allows design to evolve step by step. As new requirements emerge, the designers improve gradually. This evolutionary approach keeps the system flexible and adaptable to change. FDD's JD, just enough design initially approach. In feature-driven development, this approach is called JD, just enough design initially. It means designing only what is necessary to start development and refining the design later based on feedback. Simple design avoids the overcomplications and focus on delivering exactly what is needed, nothing more, nothing less, making the system clean, flexible, easy to maintain. And next one is business benefit. Faster delivery, less overweight, fewer delays. A simple design avoids unnecessary complexity and over planning. Teams work only on what is required now, which reduces delays caused by overthinking or rework. This makes delivery faster and more efficient. Lower cost. prevents the overbuilding, slashes wasted effort and investment. When teams only build what is essential, they avoid wasting time and money on unused features. This reduces development costs and helps organization get better returns on their investment. The next one is higher quality, fewer weakness, easier testing. Simpler code is easier to understand, test and maintain. There are fewer chances for bugs to hide in complex code paths, which improves software quality and reduces maintenance effort later. Agility. Simple code adapts more easily. Requirements change frequently in agile development. Simple and clean code, easier to modify when changes are needed. This flexibility allows teams to respond quickly without breaking the system. Increased throughput, quality and focus speed the phase of value delivery. By keeping the design simple, developers can focus on adding valuable features instead of fixing unnecessary complexity. This improves productivity and allows more value to the delivered in less time. So overall, in simple design is not just a technical practice, it delivers strong business value by reducing the cost, speeding of delivery and making the software more adaptable and reliable. Next one is simple design practice. Iterative design involves no frozen blueprint. In Agile, design is not finalized at the beginning. Instead of trying to create a perfect blueprint upfront, the design improves step by step as the product grows. This iterative approach keeps the system flexible and open to change. The next one is continuous refactoring, preserves and increases simplicity. As new features are added, the code may become messy. Continuous refactoring means regularly cleaning and improving the internal structure of the code so that it stays simple, readable, and efficient. This avoids technical debate in the long run. Value priority. Build the highest value features first. Agile team focus on delivering the business value early. Instead of building everything at once, they prioritize and implement the most important and useful features first. This ensures that the customer gets real value sooner. Modeling tools like FDD DNCs minimize the initial risk. Simple modeling tools help teams understand the system structure before building it. For example, FDD domain neutral component DNC modeling helps identify the reusable components and reduce the complexity early. This minimizes the risk and prevents the major design mistakes. So simple design focus on evolving design gradually, keeping the code clean through the refactoring, delivering the value early and reducing the risk through the smart modeling. And next one is the user stories. What are user stories? User stories are simple, informal descriptions of software features written from the perspective of the end user. They focus on what the user needs and why. Rather than on technical details, they help teams understand the requirements in a user friendly way. A short user focused requirement statement. User stories are usually short and written in a plain language. They capture what the user wants in one sentence. For example, as customers, I want to reset my password so that I can recover my account. This format keeps the team focused on user needs. XP story, key unit of value written on index card. In extreme programming, user stories are considered the primary unit of planning and development. Traditionally, they were written in the index card to keep them simple and easy to discuss. Each story delivers small but meaningful piece of value to the user. Granularity can be epics, large or simple stories. User stories can vary in size. Large stories are called epics, which may take weeks to complete and must be broken down into smaller user stories. Simple stories are small and deliver a single function usually completed within a sprint. In Agile, user stories convert business requirements into user centered goals, making it easy for teams to deliver the real value step by step. And next one is role and benefit of the user. The number one is the customer centric. User stories help the team stay focused on real customer needs instead of building the features based only on assumptions or technical ideas. User stories ensure that every feature delivers value to the end user. This keeps development aligned with the business goals and customer expectation. And number two, communication. User stories create a bridge between business and technical teams. They are written in simple non-technical language, which makes it easy for product owners, developers and testers to discuss and understand the requirements clearly. This reduces confusion and improves collaboration. Next one is flexibility. In Agile, change is expected. User stories are easy to reprioritize when business needs evolve. A team can quickly add, remove, or reorder the stories in the product backlog based on feedback, market shift, or customer request. Basis for planning. User stories help teams plan their work efficiently. Each story can be estimated based on size, risk and effort. This makes it easier to schedule work into sprints and deliver incrementally. They also help identify the dependencies and organize the delivery in the right sequence. So overall, user stories help agile teams build the right product, communicate clearly, adapt quickly to change and plan work efficiently. And next one is working with the users. Customer lead prioritization. In Agile, user stories are always prioritized based on the customer value. This means we do the most important and high impact features first instead of just following the fixed plan. Business stakeholders and product owners decide which stories should be delivered first depending on customers' needs and business goals. And next one is team collaboration. Writing and refining the user stories is a team activity. Agile teams discuss each story together to understand its complexity, risk, and dependencies. Developers, testers, and product owners work together, ensuring everyone shares a common understanding what needs to be built. And next one is the breakdown. Large user stories called epics are broken down into smaller manageable tasks. This makes it easier to complete them within a single iteration or sprint. Breaking down stories also helps the estimate time and effort better, ensure the smoother delivery. Electronic tracking. User stories are tracked using the tools to maintain clarity and organization. Teams may use the physical story cards on a Kanban board or digital tools like Jira, Trello, or Azure DevOps. This helps monitor progress, identify the blockers, and keep everyone aligned. Next one is community standardization. Teams continuously work to improve how user stories are estimated and written. They follow the agile best practices like using the inverse model and story points to reduce the variation in estimation. Over time, this improves the accuracy and delivery predictability. So, by prioritizing customer needs, collaborating as a team, breaking the work into smaller pieces, tracking the progress effectively, the following estimation standards, agile teams manage the user stories efficiently and deliver the consistent value. Next one is the agile testing. What is Agile testing? Agile testing is a software testing approach that follows the Agile principles. Unlike the traditional testing, which happens only after the development, Agile testing happens continuously throughout the development cycle. The goal is to ensure the quality from the beginning rather than finding the defects at the end. Embedded quality. In Agile, quality is built into the process. Testing is not a separate phase, it is an ongoing activity. Testers work along with the developers in every sprint, ensuring that each feature is tested as soon as it is developed. This prevents the late stage defect and reduces the rework. Agile Manifesto link. According to the Agile Manifesto, working software is the primary measure of the progress. This means the focus is not on documents or plans but on delivering the working feature that have been tested and verified. Testing ensures the functionality work as expected so that software can be released frequently. Focus on validation at every stage. Agile testing emphasizes continuous validation. Instead of waiting for a final testing phase, Agile teams validate user stories during the development using the techniques like unit testing, integration testing, acceptance testing, and automation. So every iteration delivers the potentially shippable product increments. Key principles. Technical excellence. Agile testing follows the principle of the continuous attention to technical excellence. This means that teams focus not just on finding the bugs but also improving the design, writing clean code, and using the automation to maintain the long term quality. This leads to sustainable and scalable products. So, agile testing is not just about finding the bugs, it is about building the quality from day one and delivering the working software faster. Now, we'll see the next one is business benefits of agile testing. It gives the maximized throughput, that is the quality up, more code delivered, and it is a low. It reduce the rework cost. Early defects discovery is far less expensive. Faster feedback, mistakes and mismatches are caught early because we are debugging every step. No, that's why the mistake and mismatches are caught early. Predictability, reliable quality builds trust with the clients. Next one is the key practices. Test driven development, unit testing, validate components from the start. So using the both we can validate from the start itself. And then CA builds the test for quick fault detection. Peer review, real time code checks reduce the bugs. Next one is the automated acceptance test ensure the business needs met. Customer involvement, on-site feedback, and sprint reviews. What are agile tools? Supportive scope tools enable agile workflows and collaborations. Here the core values. Individual interactions come first. Tools provide the necessary support. Visibility and automation. Tools increase team insight and automate the workflow. Example Jira, Trello, Git, Jenkins. Role and benefit. Visibility, KMS and similar platform aid self-organizing team efficiency automation example and for CI minimize the error and wasted effort planning or tracking tools enable burn down charts story tracking and more capacity boost right tools increase the developer throughput categories and example project task management, track work items, backlogs, visualize the progress, Jira, Trello, FDD, and KMS. Version control system manage the code changes, enables the CI Git. CI/CD serves build, test, deploy pipeline automation, and Jenkins automated testing frameworks. A run unit integration acceptance test JUnit. Uh, so overall summary of this session is test driven development quality built in from the start. CI real time integration strengthens the delivery flow. Refactoring constant improvement. Low tech debit. Pair programming quality plus knowledge sharing. Simple design, lean, adaptable, low overhead solution. User stories, customer centric, transparent planning. Agile testing, continuous quality assurance. Agile tools empower the teams, automate the process, boost the throughput. Thank you.